Hello, Ben, I am so sorry you couldn't tune in yesterday. My computer kept saying I'm connecting, and I checked my Wi-Fi connection, which was good, and I don't know what went wrong, which is why I sometimes hate technology. But I'm going to go through lessons 101 through 105 here for you. 104, I'm starting with 104. It's just a little bit different. It talks about triangles, and then I'm going to go through the others. I'm going to get this one out of the way first. The others are more related to one another, and they're all pretty easy. They're easy problems in that you don't have a lot of calculations to do. If you get what you have to do, the problems are quick. All right, so lesson 104 deals with triangles, classifying them by their angles, and also classifying them by the lengths of their sides. So let's start with the top here. How do we classify triangles by their angles? Triangles can be classified by one of three types of triangles. Whoopsie days. If you notice, the first triangle here has this little square down here. That means that that's a right angle. That's a 90-degree angle, and that's called a right triangle. Our second triangle here, number 2, has this wide angle there that you can tell it's greater than 90 degrees. Okay, so any triangle that has an angle that's greater than 90 degrees is called an obtuse. I like to say that word is similar to obese or fat or whatever. Okay, and then lastly, triangle number 3, all of the angles here are less than 90 degrees. They're all smaller than 90 degrees, and so that's called an acute triangle. And I like to say that all the angles are acute. All right, so they're small, less than 90 degrees. Those are the 3 types of triangles that we have according to their angles. So any triangle will either be a right triangle, an obtuse triangle, or an acute triangle, one of those 3. Now, if we're looking at their sides, the sides of a triangle, there's also 3 categories. So a triangle, if you look at triangle 1 here on the bottom, 2 and 3, if you look at triangle 1, this triangle has sides which are 3 different lengths. So 1 is different than side 2, which is different than side 3. And those hash marks don't refer to side 1 and 2 and 3. They refer to the fact that each side is a different length. What they're saying is that this is different than this, and that those 2 are different than this third leg here. So the 3 sides are all different lengths. In triangle number 2, we have what we call I didn't tell you this is called scalene, sorry. 3 different lengths, that's called scalene, right? Our second triangle is called isosceles. An isosceles triangle has 2 sides that are the same length. That is why each of these sides have 1 hash mark to indicate those are the same. And then the third side is different than the other 2. So we have 2 sides the same. Our last type of triangle, when we classify by length of sides, is called an equilateral. And this type of triangle has, as you can tell by the hash marks, all 3 sides are the same length. So any triangle can be classified into either right, obtuse, or acute, and any triangle can be classified into scalene, isosceles, or equilateral. And we can take any triangle, let's see, I'll draw one down here. You know, my drawing skills are really poor. Try again. Let's see. Okay. So if we look at this triangle drawn in red here, you can tell right away that if I were to classify by the length of its sides, it's a scalene, right? This is a scalene, right? Just S. Now, if I want to classify that triangle by its angles, we look up at the top. Is it a right triangle, an obtuse triangle, or an acute triangle? Well, it may be a little hard to see. This is actually an obtuse angle. It would be greater than 90 degrees. I probably could have drawn that more obvious, maybe if I did that. Okay. If I did that, you could tell that's greater than 90 degrees. So that would be an obtuse triangle, an obtuse scalene triangle. Obtuse and scalene. That's classifying by both angles and by sides. All right, so in your practice for this lesson, they will ask you to classify triangles by both angles and by length of sides. So you'll have to look at the triangle and decide whether it's right, obtuse, or acute, and then look at the same triangle and also decide if it's scalene, isosceles, or equilateral. All right. The other thing that they want you to know is that the interior angles of any triangle add up to 180 degrees. Okay, they all add up to 180 degrees. So they will give you a triangle and they may say, all right, if this angle is 60, and they'll draw hash marks like so, and that tells you, okay, this is an equilateral triangle. Then what are the measures of these two angles? Well, an equilateral triangle has all angles the same. These are all the same. They're all going to be 60. So then you know that this is 60 and this is 60, and that adds up to 180. They might say, let's see, I might give you a tall one like that, and they might do this. Okay, I need to add some information in here. When you have a triangle whose sides are the same, such as here, okay, when two sides of a triangle are the same, their opposite angles are also the same. So if this angle, sorry, this side and this side are equal, then their opposite angles are going to be the same. So we know that the measure of this angle and the measure of this angle are equal to each other. So if you look at my red triangle below, and if they tell you, okay, this angle up here is 50 degrees, what are the angles of, you know, let's say they label it A, B, C. What are the angles of B and C, the measures of angles B and C? You know that they're equal. You know that the interior angles have to add up to 180. So let's subtract out 50. Leaves us 130 left between angles B and C, and they have to be equal. So we just divide 130 equally into 2. That's 65. So the angles of B and C are both 65 degrees because they're equal to one another. All right, let's see. I'll do one more and then we'll move on. So they might give you a triangle like that, and they might say, let's label it ABC. Just a side note, if you see a triangle labeled, the vertices are labeled, then we can say that that is triangle ABC. That's how we denote a triangle. That's triangle ABC. Okay. They may give you a drawing like this, and they may say, what is the measure of angle A? Well, if angle C is 30, we know that angle B must be 90 because it's a right angle. 90 plus 30 is 120. They all have to add up to 180. Let's subtract out 120. We have 60 left. Angle A must be 60. So they add up to 180. And that is pretty much what they're going to cover for you in lesson 104. That's going to be, that's what the practice will entail. Okay, let's move on to lessons 101, 2, 3, and 5. I always take the long way when I do that. Just going to clear my canvas. All right, going to 101. Let's see. Okay, multiplication of exponential expressions with variable bases. All right, this is a review of exponents, multiplying expressions with exponents. So, for example, if you had 3 squared times 3 to the third, we learned in a previous lesson, I don't remember which, that if we multiply expressions with exponents, we will add the exponents together. So 2 plus 3 is 5, so 3 squared times 3 cubed equals 3 to the fifth. And just to give you an explanation of why that is, that there is 3 squared. I'm multiplying that by 3 cubed. Let me write down 3 cubed. All right. 1, 2, 3, 4, 5. I have 5 3s, so that's 3 to the 5th. All right, just an explanation why we add the exponents. The only difference in this lesson is that rather than having numbers as bases, they have variables. So they'll say x squared times x cubed, and you will say, why, that's x to the 5th. All right? Let me see how complicated this gets. Okay, now they're going to have expressions here for you to evaluate, such as, I say xy squared, x, y to the 3rd. Yeah, they only go as far as 2 variables there. And then they'll ask you to evaluate, or rather simplify this. Okay? So what we need to do is we usually go in alphabetical order. So I'm going to write my x's first. Okay. I have 1 x there and 1 x there. So when we don't see an exponent above a variable, it's understood to be a 1. So I have x to the 1st and x to the 1st. If I am multiplying them together, I have x squared, because we're going to add these. All right, now I have my y's. Let's go to the y's. Y squared and y cubed. Well, I just did that above for you. If you have y squared and y cubed, that's y to the 5th. And that's my answer right there. So it's simply a matter of adding your exponents and then ordering them in alphabetical order. All right? Let's do one more real quick. A squared, a b, a cubed, b squared. All right? Let's look at our a's. Obviously, a comes before b. This a all by itself there is understood to have an exponent of 1. So I just add those. I have 2 plus 1 plus 3. That's 6. A to the 6th. Then I have a b there, and b to the 1st there, and a b squared. Now I add 1 and 2, and I get 3, and that's it. That's all that lesson is. It's just multiplying expressions with exponents, and now we're moving to using, we have variables as our base rather than just a number. Okay, that's all that lesson 101 is. In lesson 102, we are adding like terms, part 2. This is, they call it part 2. Let's see. Go to my practice. Okay, now we get into slightly more complicated expressions. When we did like terms before, we might have had 3x plus 2y plus y plus x. All right? And then we would see we had 3 x's there and an x there, and then we had 2 y's there and a y there. All right, now if I'm adding like terms, we're looking at our variables. An x to the 1st and an x to the 1st are like terms. If one of them was squared, they would not be like terms, and I could not add them together. But since they are both x to the 1st, I can add those two together. So here I have 3, and there I have 1. 1 meaning 1. That coefficient there is understood to be 1, and that's 4. So I have 4x. All right, now let's look at my y's. I have 2 there, and again, 1 there, and that's 3. And that would be the simplest I could go there, 4x plus 3y. In this lesson, it's the same idea, but our expressions get more complicated. So you might see something like 3xy, or 2x squared y, or 4x squared y squared. These are all unlike terms. None of these could be added together. In order to add like terms, the variable and the exponent attached to it have to be the same. So I have to add an x to an x squared to an x squared, or an xy to an xy. Okay, I cannot add xy to x squared y. I cannot do that. So let's look at a long phrase, I guess an algebraic phrase, and we'll simplify it. All right, so if I have 3xy plus 2x squared y plus xy plus 5x squared y squared plus x squared y. All right, now we want to add like terms here. Let's first figure out how many different terms do I have. I have an xy here. There's an xy. That's it. All right. Then I have an x squared y there and an x, mistake, sorry. I'm looking for x squared y. The variables and the exponents have to be identical. Oh, goodness. Okay, right there. I erased part of the y. And then I have just one of these. There's only one x squared y squared. Now, typically we start with the simplest term, which would be xy. So let's add those first. I've got 3 here, and this is understood to be 1. I've got 1 there, so I have 4 of them. All right, and then let's go to the next simplest, I guess, would be x squared y. I've got 2 there, and what's understood to be 1 there, so I have 3 of those. 3x squared y's. And then lastly, I have the 5x squared y squared, and I had only 1 of those type of terms. And that is my answer. All right? So all you have to do here is pick out, you have to look carefully at each term and make sure that they are the same in their variables and in their exponents. And then you just add them up. All right? And don't be adding the exponents here like, we don't add, this and this. Don't get confused with multiplying terms. Here we are adding. When you're adding like terms, you don't change any of the exponents. All right. So that is lesson 102. All right, let's go to 103. It's the distributive property. All right, we covered the distributive property way back when we talked about distributive, commutative, and associative, maybe a few others. All right, the distributive property tells us that if we have a number outside some terms in parentheses, that this number, this 3, gets distributed over each term inside the parentheses. So we know that when there's a number sitting there right next to another, a set of parentheses, that indicates multiplication. So this means I must multiply 3 by the 2, and that's 6. I want to preserve my plus sign here, and I'll drop that down. And then I multiply my 3 by my 7, and that's 21. And the whole thing there is 27. So the distributive property tells me to take a number outside a set of parentheses, or any symbol of inclusion. It could be brackets or braces too. But in this lesson, let's see, do they use the other? No, we're only using parentheses here. But if there was a 3 outside a set of brackets, that would also indicate multiplication. So we just take our number outside of our symbol of inclusion, in this case it's parentheses, and we multiply that 3 by each term inside. So that's what we learned previously. In this lesson, no surprise, they're going to use variables now. So we're going to have something like 2x times x plus 3. So we have to remember our rules for multiplying variables with exponents. Okay, so I'm going to take my 2x and multiply it by x, and then I'm going to add that to 2x multiplied by 3. What is 2x times x? Remember that these x's here have an exponent that's understood to be 1. When we multiply a base with variables with exponents, we add their exponents. So that's going to be 2x, and we add those exponents, that's 2x squared. I'm going to drop down my plus sign there, and now I'm going to multiply 2x times 3. This is just 2 times x times 3. Remember that we can multiply in any order, so I'm going to make that 2 times 3 times x, and then I'm going to simplify 2 times 3 to 6, and this becomes 6x. In other words, when you multiply terms that have coefficients and constants, we multiply the numbers together. Okay, let me do another one. All right, let's say 2x times 4x squared plus 6. Okay, so I want to multiply 2x by 4x squared. That's 2x times 4 times x squared. And I can multiply these in any order, so I'm going to multiply my 2 and my 4, that's 8. And then my x to the first and my x to the third, my x to the first and my x squared become x to the third. Because I add the exponents, I add these. Right, so my first term becomes 8x to the third. Now I want to multiply 2x by 6. That's just 2 times x times 6. I'm going to multiply my numbers first, and that becomes 12x. So then of course I got to keep my plus sign there, and my second term is 12x. That's it. I think they throw in one in the practice where there's 3 terms inside the parentheses, something like 2x times 3 minus x minus y. Throw in some negative signs just to make it a little more error prone. All right, so same thing, I'm going to take my 2x multiplied by 3, then I'm going to multiply it by x, and then multiply it by y. And I'm going to preserve my subtraction signs here. 2x times 3 is the same as 2 times 3 times x, and that's 6x. Drop down my subtraction sign. 2x times x is 2 times x times x. These are understood to be 1 each, so that becomes 2x squared because I add these. Right, so that's my second term, 2x squared. I'm going to drop down that negative sign there, that subtraction sign, sorry. And then my third term is going to be 2x times y, which is 2 times x times y. That doesn't get any simpler than that. It's just 2xy. That's my answer. Okay, and that's what you're doing there in lesson 103. Now I'm going to skip to lesson 105. Okay, I'll clear my canvas. Uh-oh. Sorry. Okay, back in business. All right, in lesson 105, it's evaluating powers of negative bases. If you recall, I think it was lesson 99, we talked about being careful when you're using signed numbers with exponents to be careful how you evaluate them. This here is not negative 3 times negative 3. This is negative 3 times 3. Only the base just immediate to the 2 here is raised to the second power, and then we apply the negative sign. So it would be 3 times 3, which is 9, and then we apply the negative sign. This here, on the other hand, because the negative 3 is in parentheses, that means you are to raise the entire negative 3 to the second power. A negative times a negative is a positive, and it's a positive 9. It's very important not to raise the negative 2 along with the 3 to the second power unless the entire thing is in parentheses. Right? So that's what we learned about signed numbers and exponents. And here, again, we're just going to be doing, we're going to be doing expressions with variables and exponents, and then we're going to be substituting for values that are negative. So let's say a is negative 3, and B is negative 2. Right, I'm going to throw a squared in here. So now what you want to do when you are substituting with signed numbers is make sure that they're all inserted with parentheses. So a squared would become negative 3, because the a is, you have to insert the entirety of a and raise that to the second power, and that's negative 3. And then b is negative 2, and then keep them all in parentheses for simplicity's sake. You'll make less errors. For sure you have to keep the variables that are raised to exponents, those must be in parentheses. Okay. But what I'm saying is also put, this, not that, put that in parentheses also. All right, now we just have to do the math here. If you look at this, that's 3 times 3 times 2, that's 18. And we have 1, 2, 3 negative, we're multiplying 3 negative sign numbers, 3 negative signs. That's an odd number, that's negative. Drop this down. And then down here we have 3 times 2 times 2, which is 12. And again, we have 1, 2, 3 negative signs multiplied together. That makes that negative. So that becomes negative 18. When you subtract a negative number, you add it. And then negative 18 plus 12, we're at negative 18 on the number line, and we go in the positive direction 12, we're going to end up at negative 6. And that's all lesson 105 is. That's really all the practice gives you there. So that's lessons 101 to 105. Okay, good luck, and text anytime or email if you have any trouble. Signing off.